Hi there, Mr. Muhammed is here. This is revised for Checkpoint Book, Unit 13. This is about fractions and percentage. 13.1. This set of exercises about arithmetics with fractions. Arithmetics means addition, subtraction, multiplication, and division. Let's see how can we deal with fractions and mixed numbers with arithmetics. Question 1a, which is a very simple case. It's 1 over 6 plus 1 over 2. Okay, how can we add these two fractions? Firstly, we need to have the common denominator. The common denominator for 6 and 2 is 6. Okay, how 6 becomes 6? It's multiplied by 1 and the top must be multiplied by 1, just like the bottom. And here how 2 becomes 6 if we multiply it by 3 and the top must be multiplied by 3. Now 3 times 2 is 6, 3 times 1 is 3, 1 times 6 is 6, 1 times 1 is 1. Now since we have the same denominator, we can just add the numerators together. 1 plus 3 is equal to 4 over 6. Since the question says write the answer in the lowest possible term. Lowest possible term, in other words, means simplest form. Then to simplify a fraction, we are going to divide up and down the numerator and the denominator by the same number. As you see, 4 and 6, they both even numbers, so we can divide both of them by 2 and divide this by 2. We will get 4 divided 2 is 2, 6 divided 2 is 3. 2 over 3 is the lowest term for question 1a. Question 1b, A was a simple case because 6 is a multiple of 2, so easily we can get the common denominator. What if we have something like this, 8 and 3, while none of them is multiple of the other one? Then to do such addition, 5 over 8 plus 1 over 3. So simply we just multiply them, or we're going to find the lowest common multiple between these two numbers. Let's write some multiples of 8, multiples of 3, and see which number is the lowest common multiple. Multiples of 8 are 8, 16, 24, 32. Let's write some multiples of 3, 3, 6, 9, 12, 15. Nothing repeated so far. 18, 21, 24. So 24 is the lowest common multiple between 8 and 3, so it will be the common denominator. Or when you see numbers like this, 8 is not a multiple of 3, then just multiply them like 3 by 8 and 8 by 3 to get the common denominator. So this fraction here will be multiplied by 8, and this one will be multiplied by 3 just because of the denominators. Now we got 24 as the common denominator. Okay, 1 times 8 is 8, 5 times 3 is 15. Now all we have to do, add them and then simplify the results. 5 plus 8 is equal to 23. 15 plus 8 is equal to 23. And the denominator is already 24. Well, these two numbers, we cannot divide 23 and 24 by a number. It means this is the lowest term. Question 1b is 23 over 24. Part C, it's the same idea repeating, and part D is similar to part A because 6 is a multiple of 3. Then the common denominator here is 6. The common denominator between 4 and 5 is 20. Now let's move on to question 2, subtraction. Okay, question 2, a 1 over 2 minus 1 over 4. So it's the exact same process. Firstly, we need to find the common denominator. Between 2 and 4, 4 is the common denominator. Then how 2 becomes 4 if we multiply it by 2 and multiply this by 2. This one is multiplied by 1, because it's already 4. If we multiply it by 1, it stays 4. This step is not necessary, multiply by 1, but this one is necessary. Now 1 times 2 is 2. 2 times 2 is 4, it's correct. 1 times 1 is 1. 4 times 1 is 4. Now we have the same denominator, we can just subtract the numbers. 2 minus 1 is equal to 1 over 4. And there is no number that can divide 1 and 4 at the same time, so it's the simplest form. Part B, question 2b, 7 over 10 minus 1 over 2. Then the common denominator will be 10. Then how 2 becomes 10 if we multiply it by 5. And whenever you multiply the denominator by a number, you must multiply the numerator by the same number. There we go. 7 over 10 minus 5 times 1 is equal to 5. 5 times 2 is equal to 10. Same denominator, just simply subtract the numerators. 7 minus 5 is 2 over 10. 2 and 10, they both divisible by 2, so the lowest term will be 1 over 5. After we divide 2 and 10 by 2. 2 divided 2 is 1. 10 divided 2 is 5. Done. So question 2b is 1 over 5, the final result. Now let's move on to mixed numbers. Remember, the questions that I don't do here, it has the same idea here. It has the same idea as this one. This one has the same idea as part A. Even here, they all have the same idea. So the questions that I don't do in this lesson, these are your tasks. You have to do it on your own, and you got what you need to do it. Now, mixed numbers. When we have mixed numbers like 2 1 over 4 plus 3 1 over 2. To add these two mixed numbers together, there are some ways that they work in some cases, but what I tell you now, it's always working for all the cases of mixed numbers. And the way is, return these numbers back into improper fraction, then add them just like two normal fractions. Now, how can we return this mixed number into an improper fraction? To do this, we multiply these two numbers, and the result of this multiplication plus this one, and the denominator will not change. 4 times 2 is 8, plus 1 is 9, so this fraction will be 9 over 4. The denominator won't change, plus 2 times 3 is 6, plus 1, 7 over 2. Now to add these two fractions, we need a common denominator, which is 4. How 2 becomes 4 if we multiply up and down by 2? Then we will have 9 over 4 plus 2 times 7 is 14 over 4. Now add these two numbers. 9 plus 14 is equal to 23 over 4. 9 plus 14 is equal to 23 over 4. Now, since the question says lowest term, improper fraction, when you see the numerator is greater than the denominator, it means it's not in the simplest form. It's not lowest term. We have to represent this improper fraction as mixed numbers. The mixed numbers are like this: 23 over 4. You can simply say how many 4s are there in 23? It's 5. There are 5 4s in 23. So what's remaining if we take out 5 4s in 23? 5 times 4 is 20, so what's remaining is 3, and the denominator never changes. Again, we can also use division. 23 divided by 4, it will be 5. And the remainder is 3 over 4, which is the divisor. 3 over 4 is the answer of question 3a. 3 over 4. Question 3b, it's subtraction of two mixed numbers. Two 5 over 6. 2 5 over 6 is question 3b, minus 1 over 3. We're doing this. 2 5 over 6 minus 1 over 3. Okay. Firstly, we need to return these mixed numbers back to improper fraction. Then 6 times 2 is 12, plus 5, it is 17 over 6, minus 3 times 1, 3, plus 1, 4 over 3. Now the common denominator for these two fractions is 6. Then this one must be multiplied by 2 times 2 times 2. Then we have 17 minus 4 times 2 is 8 over 6. 17 minus 8 is equal to 9 over 6. 9 and 6, they both divisible by 3, but before we divide them, you see the numerator, the top, is greater than the number on bottom. So we have to represent these as mixed number. How many 6 are there in 9? There's only one 6 in 9. What's remaining if we take out 6 from 9? 3 over 6. Now this 3 over 6 could be simplified. So 1, which is the whole part, doesn't change. 3 and 6, we can divide 3 and 6 by 3. 3 divided 3 is 1. 6 divided 3 is 2. The final answer of question 3b is 1 over 2. The rest are your task. Now multiplication. Multiplication is one of the easiest arithmetics with fractions, because simply only for multiplication we multiply the first number, the top number, by the top, and the bottom number by the bottom number. Question 4a, it's 2 over 3 times 3 over 11. So remember, it is only for multiplication when you can multiply these two numbers together, to get the result. 2 times 3 is 6, 3 times 11 is 33. 6 and 33 are both divisible by 3, then we will get 2 over 11. This is one way. The other way, to do the exact same question, 2 over 3 multiplied by 3 over 11, we can always simplify before we multiply for multiplication. So we can say this 3, because it's on the top, will be cancelled with this 3 because it's on the bottom. We cannot cancel two numbers on the top or two numbers down, but we can cancel one number on the top with a number in the denominator. So this one works. If these two numbers are both divisible by a number, for example by 2 by 3, we can divide them and make them simpler. Then we do the multiplication. So what did we do here? Divide 3, it will be 1. Divide 3, it will be 1. Now let's see what we have to deal with. We have only 1 left over here. 2 times 1 is 2. And 1 times 11 is 11. Look, we got the same answer. So which way you happy with? Follow your way. Don't confuse yourself. Follow one way, because they always give the exact same answer if you do any of them properly. Focus on one way and make yourself faster and more comfortable with the way that you like. Question 4b. Question 4b. So this one was 2 over 11. Question 4b, it is 5 over 7 times 14 over 15. Now look at the 5 and the 15. We can divide both of them by 5. Then divide by 5. It will be 1. You can also write this for yourself. Divide by 5, it will be 1. Divide by 5, it will be 3. 7 and 14, they both divisible by 7. Then divide 7, it will be 1. Divide 7, it will be 2. This is divide by 7, it will be 2. Now we have only these numbers to multiply them by each other. 1 times 2 and then 1 times 3. It's better to box the final numbers, then you don't mix up. Here 1 times 2 is 2, 1 times 3 is 3. 2 over 3 is the final answer of question 4b. So this is 2 over 3. Now for division, we have 2 over 9 divided by 5 over 6. With one easy step, we can reduce division into a multiplication problem. And as you know, multiplication is easy because we just multiply the top numbers together and the bottom numbers together. Here 2 over 9, this is question 4c. 2 over 9 divided by 5 over 6. How can we divide these two fractions? Simply, division will be multiplication when we follow KFC. Oh, it makes me feel hungry. KFC. What does that mean? KFC means keep the first fraction, 2 over 9. Then flip the second fraction, 6 over 5. Look, it was 5 over 6, it became 6 over 5. And then C means change the division to multiplication. Again, KFC, K means keep the first fraction. F means flip the second fraction. C means change the division to multiplication. Now, you are quite familiar with multiplication. Now, this problem does not exist anymore. Now we have this to solve. And as you know, in multiplication, we can simplify before we multiply. How? Here, 6 is divisible by 3. Divide 3, it will be 2. 9 is also divisible by 3. That's why we divide both by 3. We cannot divide only one number by another number. No. Only when you see two numbers like this, they both divisible by a certain number, like 3 here, then we do the simplification. 9 divided by 3 is equal to 3. So these numbers are the last ones that I have to multiply them out. 2 times 2 is 4. 3 times 5 is 15. So 4 and 15, we cannot divide both of them by 2 or by 3 or by any other number. Then this is the final answer, 4 over 15. Question 4D, 3 over 8 divided by 9 over 10. 3 over 8 divided by 9 over 10. To do this one, is there any simplification? For now, no, there's no any simplifying. We cannot simplify 3 with the 9, no, because they both in the numerator. Then follow KFC, keep the first fraction, 3 over 8. Flip the second fraction, 10 over 9. Look, 9 over 10 became 10 over 9. Change division to multiplication. Now, as a multiplication problem, can we simplify this? Yes, by 3, it will be 3. Divide 3, it will be 1. 1 times 10 is 10. 8 times 3 is 24. 10 and 24, we can divide both of them by 2. Then we will have 5 over 12. 5 over 12 is the final answer for question 4D. Remember, we simplify up and down only in multiplication problem. Never simplify a division problem like this unless you reduce into multiplication. Then you can simplify the multiplication. There are ways that you can simplify a division problem, but no, I'm telling you some tips that they always work. Okay? So, as math, never depend on some ways that they work only in a few cases. No, focus on the ways that they work all the time. Now question 5, it's mixed number. How can we multiply two mixed numbers? Two 6 over 7 times 3 4 over 15. Whenever you deal with mixed numbers, the safest way is to reduce into improper fraction, then deal with the fractions, not mixed numbers. Because this way is always true. You always get the perfect correct answer. 7 times 2 is 14, plus 6, it's 20 over 7. Again, to reduce a mixed number into improper fraction, multiply this 2, add the result to this one, and the numerator, which is the 7, never changes. 7 times 2, 14, plus 6, 20, times 15 times 3 is equal to 45, plus 4 is 49 over 15. Here, since it's a multiplication problem, we can divide the numbers, make them simpler, like the 6 and the 15. we can divide them by 3. This one will be 2, this one will be 5. But it's better to reduce the mixed number into improper fraction than do the simplifications. Now we have just a normal multiplication problem. We can simplify this to divide 7, it will be 1. Divide 7, it will be 7. And then here divide 5, it will be 4. Divide 5, it will be 3. Now we have only these numbers to be multiplied. 4 times 7 is 28. 1 times 3 is 3. 28 over 3. We cannot divide 28 by 3. So let's just write this improper fraction as mixed number. 28 divided by 3 is equal to 9, because 9 times 3 is 27. What's remaining is 1, and the 3 never changes. This is the final answer. To check this, will we get the 28 back? 3 times 9 is 27, plus 1 is 28 over 3. Yes, 1 over 3. 9, 1 over 3 is the answer of question 5a. Question 5b, it's again multiplication with mixed numbers. Four 1 over 2 times 2 1 over 3. These ways that I explain here, they work without calculator. If you see some questions like this in the calculator paper in checkpoint, you better use calculator because it saves time. Here, 4 1 over 2 times 2 1 over 3. To reduce these into a improper fraction, here 2 times 4 is 8, plus 1 is 9 over 2, times 2 times 3 6, plus 1 7 over 3. Now multiply. Can we simplify before multiply? Yes, we can divide this by 3, it will be 1, and divide this by 3, it will be 3. 3 times 7 is 21, 2 times 1 is 2. Now 21 divided by 2 is 10. This 2 never changes, it's denominator. 2 times 10 is 20. What's remaining from 21? It's just 1. The answer here is 10, 1 over 2. For division with mixed numbers, kind of we do the same thing. Reduce the mixed number back into an improper fraction, then follow KFC. Change the division problem into a multiplication problem and do the multiplication. 2 1 over 2 divide by 3 1 over 8. And the first thing we do to write this in improper fractions. 2 times 2 is 4, plus 1 is 5. 5 over 2 divide by 8 times 3 24, plus 1 25. 25 over 8. Now follow KFC, keep the first fraction, flip the second fraction, change the multiplication, change the division to multiplication. Keep the first fraction, 5 over 2, flip the second fraction, 8 over 25, and change division to multiplication. Before we multiply, there is some simplification. We can divide this by 5, it will be 5. We can divide this by 5, it will be 1. 8 and 2, they both divisible by 2, it will be 4. And this will be 1 after we divide it by 2. Now, 4 times 1 is 4. And 1 times 5 is 5. 4 over 5 is the final answer here. It's okay if you get a proper fraction from the division or multiplication of two improper fractions. It's fine. So this is 4 over 5. And the final question in this set is 4, 3 over 2. Four 3 over 2 divided by 3 1 over 2. It's 4 2 over 3. 4 2 over 3 divided by 3 1 over 2. Okay. Reduced into an improper fraction here. 4 times 3 is 12 plus 2 14 over 3 divide 2 times 3 6 plus 1 7 over 2. Now change this division problem to a multiplication problem. Keep the first fraction, flip the second fraction, 2 over 7. Now 7 and 14, we can divide both of them by 7, then divide 7, it will be 1, divide 7, it will be 2. Finally, 2 times 2 is 4, 3 times 1 is 3. 4 is greater than 3, we have to write this as an improper. This is improper fraction, we have to write it as a mixed number. Then, how many 3's are there in 4? There is only one 3 in 4. What's remaining is only 1, and the 3, which is the denominator, never changes. To check, 3 times 1 is 3 plus 1 is 4, so we got the 4 back. This is the correct answer. 1 over 3 is the final answer here. This set done. Remember to do the questions that I didn't do here and this one. These are your tasks. Try to do them on your own. Comment below whatever question you have.